let's go over some of the types of the problems that you will see on today's assignment. So some of the problems that you're going to see are just going to be factoring. And so whenever you have a problem like this, the first thing you want to do is plug in your 2 to make sure that you do get 0 over 0. And here 2 squared is 4 minus 4 times 2, which is 8, so that would give you negative 4, plus 4, that equals 0. And then, of course, 2 minus 2 is also 0. So direct substitution gives you 0 over 0. So that tells us that we need to do something to simplify this. So I'm going to do the limit as x approaches 2. I'm going to factor the numerator into x minus 2 times x minus 2. And that'll be over x minus 2. So one of these sets of x minus 2's can cancel. And then so after that, you just need to plug in your 2. So you'll have 2 minus 2, which will give you 0. So 0 is your answer. Remember, 0 is an answer. It's not undefined or does not exist. It's the number 0. Okay. So some of these will be like what we have already done. And then you will have some others that will be a little bit different. So this next type of problem is one that you'll see that I don't believe you've seen yet. And so right here, there's nothing that I can factor. What I'm going to have to do on this one first is I'm going to have to actually expand. So remember that 3t plus 1 squared, that is 3t plus 1 times 3t plus 1. So you got to distribute there. Or I am actually just going to square, double square for that. And I should have plugged in that 0 to make sure you get 0 over 0, but you do get 0 over 0. So 3t plus 1 squared, if I square, double square, I'll get 9t squared plus 6t plus 1 minus 1 over 2t. Well, this plus 1 minus 1 right here is going to cancel each other out. So you really just have 9t squared plus 6t over 2t. And so what we're going to do is we're going to factor a t out of that numerator. You could take a 3t if you want, or just a t. It really does not matter. And we've got a 2t in the bottom. And so what can happen is these t's on the top and bottom can cancel. And once those cancel, we can just plug in 0 for our t. So we'll have 9 times 0 plus 6 over 2. And that's going to give us 6 over 2. So 3 is our answer. So it's very similar to what you're doing on the other problems as far as the factoring goes, but before you are able to factor, you have to expand this expression right here. And that would be the case whether or not it's on the top of the fraction or the bottom. Okay. The next type you're going to see is a lot different than the ones that we've done before, because you're going to see square roots in these problems. And so the square roots, what we have to do is we have to get rid of the square root in whichever side of the fraction it's in. It's called rationalization. I have made you guys before rationalize square roots. So let me just put myself a little bit of room over here to the side to remind you of what rationalizing square roots looks like. If you got an answer, let's say you were doing unit circle, and you got the answer of 2 over the square root of 2. Well, that would not be a valid answer. So what you had to do for that is you had to multiply the bottom by the square root of 2 and the top by the square root of 2. And so whenever you do that, you'll get 2 times the square root of 2 over square root of 2 times square root of 2 is 2. And then these two cancel, and you just end up with square root of 2. So that is the main type of rationalization that we have done. However, there's another type that I think you looked at in Math 3, and it would be something like this. If I had 1 over the square root of 3 plus 2, like that, then I have a square root in the denominator and I want to get rid of it. So in order to get rid of it, I have to multiply by the conjugate. And so the conjugate would be, we would just change this plus right here in the middle to a minus. So we would have square root of 3 minus 2. And we'd have to multiply on top and bottom by that. And here's the reason that that works. Square root of 3 times square root of 3 is just 3. So this is the denominator. Square root of 3 times negative 2 would be negative 2 square root of 3. But positive 2 times the square root of 3 is positive 2 square root of 3. And then this last part right here would be a minus 4. So these two middle terms right here cancel. It's a difference of squares. So what you would end up with for this, you'd have your square root of 3 minus 2 on the top. And so you'd have square root of 3 minus 2 over right here. We've got 3 minus 4, which gives us negative 1. You would probably even see that simplified to where we divide both of those by negative 1. So negative square root of 3 plus 2 there is probably what you would see that simplified to. So both of those things are called rationalizing the denominator. Now for limits, what we're going to do is we're going to rationalize even if what we have is on the numerator. We just want to get the square root to the other side of the fraction. So typically you're going to see minuses instead of pluses right here for that, because otherwise you don't get a 0 in the denominator. And so if you plug in 1 here, you get 0 over 0. So what you're going to do is you're going to take this and multiply by the conjugate. So you're going to multiply by t plus 1 in the top, or square root of t plus 1, I should say, in the top and the bottom of this fraction. And so that's going to give you the limit as t approaches 1 of t minus 1 times the square root of t plus 1. Do not multiply those together because you want something to cancel, so you want that to continue to be factored. And if you multiply here, square root of t times square root of t is t. And then you'll multiply on the outside and you'll get plus the square root of t. And right here on the inside you'll get minus the square root of t. And then for your last terms, you get minus 1. So this great thing happens here, and those middle terms cancel out. And so now we've got limit as t approaches 1 of t minus 1 times square root of t plus 1 all over t minus 1. And now those t minus 1s can cancel. And so once they have canceled, we can just plug in the 1 for our t. So we'll have square root of 1 plus 1, which is just going to be 2. So 2 would be our answer for that problem. Okay, here's another example like we just saw. And so for this one, you would want to rationalize that denominator. So you would have to multiply by x plus 3. I'm sorry, square root of x plus 3 and square root of x plus 3. And so that is going to give you the limit as x approaches 9 of x minus 9 times the square root of x plus 3 over, and right here we'll have square root of x times square root of x is x. And you'll see because we're multiplying by the conjugate, we're going to have this happen every time. We get positive 3 square root of x and negative 3 square root of x. So those middle terms are going to cancel out. And then we just have to multiply negative 3 times 3, and we get a minus 9. And so what we see here is those x minus 9s can cancel. The last thing we have to do is just plug in that 9. So we'll have square root of 9 plus 3. And that is going to be 3 plus 3, which is going to give us 6 for our answer. Let's do one more of those. Okay, you'll notice here your square root is actually in the numerator of this problem. And so we still are going to rationalize. We'll just rationalize the numerator here. So we are going to take this numerator and multiply by the square root of x plus 5. And in the denominator, we'll multiply by the square root of x plus 5. And just like on the other problems, it's going to be the same. The only difference is that your square root is on the top for this one. So we want to multiply these together. Square root of x times square root of x is x. For the outside terms, we'll get positive 5 square root of x. For the inside terms, we'll get negative 5 square root of x. And for the last, we'll get minus 25. And so here, we'll have x minus 25 times square root of x plus 5. Right, and our x minus 25s can cancel. And at this point, all you've got to do is plug in your 25. So you're going to have 1 over the square root of 25 plus 5. And square root of 25, of course, is 5. So we get 1 over 10 for our answer here. So that is how you rationalize a limit so that you can cancel and solve. Go ahead and do the section on IXL. If you have any trouble, let me know.